10th grade folder. That's what I need. Ah. 10E, 10E. Hello. Nobody there. E. There's some folks. Hello. Good day. Oh, there's a bunch. Hold on. Whew. Okay, you guys are quick. All right, today's the third, no, the first of the third. 1, 3. Good, I got Lily. I got Noah. Thank you, Noah. And I've got Lee, and I'm doing well. Lee and Lena and Shilpa. Lee, Lena, Shilpa. And I've got Deacon, Julian K, and Isabella. Super. Thanks for showing up, everybody. Deacon, Julian K, Isabella. I've got Julian L. I got Priya. I got Tom. Julian L. Priya. Tom. Keep it coming. Keep it coming. I got Magdalena, Larissa, and Tadashi. Magdalena, Larissa, Tadashi. Oh, they're coming fast. I got Nicholas and Sarah. Ahua. Good. I got Merla. Do I have a Natalie yet? I do. There's Natalie. Look at that. Okay. Do I have an Aiden K? Do I have Riley? She said she might be late. Christian. Do I have Dominic, Ali, or Vincent? Any of those folks? I'm guessing the answer is not yes. Okay. So let's go ahead and begin. Any questions from you about the last assignment with drawings and stuff? Everything going okay so far? Hope you're doing well. Oh, there's Ali. Thank you, Ali. So any questions from all of you? Maybe from Sarah. My Wi-Fi is being a bit weird this morning. Did you see my comment? No, I didn't, but I understand now. If you go off, then you'll have to, Sarah, watch the video version. My Wi-Fi crashed with AP Chemistry. So if I crash, folks, I'll delete the video and then I'll start a new one, just so you're aware, okay? All right. As long as they are connected by their electrical charges, does the exact angle matter? No. We're going to go on today to something new, but involving now back to our original topic, alcohols. I know we got what you might have thought of as sidetracked with all of this intermolecular forces stuff, and yet we'll use that throughout the semester. So it was not for naught, as we say in high English. Let's go ahead and begin with this process today, fermentation. Unless I've got anybody else out there who needs to say hello and or any questions. Okay, so I'm still missing Vincent and Dominic, Christian, Riley, and Aiden. Everybody else is here, which I appreciate. Go. So fermentation. I'm going to send you a couple of sheets to read. Ta-da! I'm going to send you this, but I'm going to give you the highlights today and also talk about some stuff that's rather important. Okay, so here's the deal. To get to get fermentation, right, which is the process of making ethanol, to make ethanol, here it is. I take glucose, C6H12O6, and that's, of course, a solid, although it can be in solution. I'll leave off the phase. Pardon me. And I need to do this in the presence of yeast. We'll see why in a second. Okay, we'll talk about yeast. Yeast are super important, as it turns out. Okay, so what do I get? I get ethanol, C2H5OH, plus I get your friend and mine, CO2. Just kidding. It's not good, but we get it anyway. Plus we get energy. Because we get energy, it's a thermic reaction. Who's had that word? Thermic. Just seeing if you're awake this morning. Thermic process. If I give off energy, one person has it. Let's see if some others are checking in, because I get a lag time, so I don't always get everybody. Thank you, Shilpa, Tadashi, Magdalena, and Noah, and Larissa. It is indeed exo. Think of like going out an exit from a room. Energy is leaving. It's leaving the system. There's my system. So it's being created from the chemical reaction. Ute, let's balance this sucker. I got C6, so I actually need 2 of these and 2 of these to get enough C's. That's hard. I know, but I think now it comes out right. I got 2 O's plus 4 O's. I get 6 O's, 12 H's. 6 times 2 is 12 H's, and 6 C's. 4 plus 2 is 6 C's. Now it is indeed balanced. Good. So yeast contain enzymes. What are enzymes from last year? At least those that had me, I think. We talked about enzymes. Enzymes. What are enzymes? Yeah, they are proteins of some sort, which we'll talk more about this year, Tom. But I guess I would say, what do enzymes do? What do enzymes do? To quicken the process. There you go. Thank you, Shilpa. So these are catalysts. Well, I should write here. These are biological catalyst. I hope you've had the word catalyst. Yes, yes, no, no. Catalyst? Yes, Magdalena? Right. So biological catalyst do kind of what Shilpa said. They speed up reactions. But they're not used up themselves. You know what I'm saying? They can be used over and over and over, but not used up. Enzymes or yeast is also like a bacteria, okay? So it's a living creature as well. So you might have had some of this with Mr. Lee or Ms. Galloway or somebody, okay? And that's important because of some of the stuff that happens with fermentation, all right? For example, problem. Let's see if I got any questions. No, we're doing okay? All right, so the problem is, well, you tell me, what's the problem, gang, if this is an exothermic reaction? What's the problem with the little yeasty fellows? It's exothermic. You got a big container and Okay. Vincent, thank you for checking in. Okay. What's the problem with this being exothermic, everybody? Yeah, the bacteria will heat up. And if they heat up too much, what do the bacteria do? They die. Exactly, Magdalena. So heat eventually can kill bacteria. Whoops, I didn't mean to capitalize that, but you get the idea. The solution, so frankly, it's a bit like Corona time. You need good ventilation to keep them cool. Good ventilation to cool. And I'm going to raise the top and talk about another, I say problems. Here, let's label these A. Okay, B. What if it's too cold? What's your problem if it's too cold? Can you guess? They don't necessarily die. Let's just say they stop working. Yeast stops working. Do you guys ever make bread? It's worth making just to understand how it works. You take some yeast first, some powder, or like a little bit of yeast you can buy in the grocery store, and you mix it with warm water, right? Warm water. And then, and if it's the powder stuff, you got to add a little sugar and let it sit there, okay? And it's got to be in warm water so the stuff can start. If you put it in cold water, you're going to be there all day, okay? It needs to be a nice temperature, and this sheet will give you the temperature range for that, but you get the idea. Okay, so here's another problem. Alcohol is a poison, including ethanol. Yeah, exactly, Magdalena. Right. Okay. Okay, so new problem. Alcohol is a poison. What's the problem for the little yeasties? Yeah, I don't know about burst open, but they die. You may know more about this than I do, Tom. The yeast microbes, exactly. Right. So, yeah. So alcohol is a poison which eventually kills off the yeast. So mostly we can get a maximum alcohol percentage of like 18 to 20%. So maximum percent alcohol is 18 to 20%. Now I want you to think about where this is happening. We're talking like beer and wine. Really, beer is much less. So beer is like, it varies by the beer. The beer could be like 3 to 8%. We're talking here more like about wine, all right? Wine has a higher percent alcohol. You'll get the data later in the week. Good. Let's see. Good. Okay. Noah asked a good question about disinfectant. Noah, we're going to talk. In fact, I'm going to write it in the corner so I don't forget it, Noah. If I forget it, you like bang on the computer. I want to talk to you about spiritus, but let's finish this too. That's a disinfectant in Germany. Spiritus, Espiritu Santi. No, just kidding. Yeah, spiritus. So we'll talk about what that is and what it is not eventually. So here's the deal. If you being the manufacturer, I'm not asking you to make high alcohol stuff. You're actually not allowed to until you're 18 anyway. If you want a higher percent alcohol, then you need to use a process called distillation. Distillation. I think I showed some of you this last year. I hope so. Does that ring a bell? Did we look at a distillation last year? We should have looked at it when we talked about alkanes and oil refineries. They use a distillation process also. We did. Thank you, Tom. Thank you, Magdalena. Okay, so if you haven't had distillation, you may want to look this up, but basically it divides water and alcohol by heating them up by their boiling temperatures. Can I say boiling point, BP? Well, you know what that is? So that's what distillation is. So if you want to make whiskey, vodka, whatever, okay, you're going to be, okay, so we'll say distilleries, here's how you spell it in English, distilleries, hope I spell it right, make whiskey, vodka, blah, 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 with distillation. Okay, with this process. Beer and wine you can make at home. And once it stops working, it's okay. That means the yeast are done and you've hit a certain percent. And Sarah vaguely remembers too. Thank you, Sarah. Okay. Before I go on, I'm going to come back to alcohol. Let's talk about spiritus for a second because Noah gave me a good heads up. What does the BP stand for? Okay, I'll just write it here next to it, Lee. BP stands for boiling point. Like, Lee, water boils at 100. Alcohol boils at less than that. It's on the data sheet I gave you. I don't know if it's 60 or 70 Celsius, but so if I have a cup, if I heat it up, the alcohol steams off first, and I can recapture that, and that's distillation. The water stays behind. And so I get a product that has a higher percentage of alcohol. I can even distill it several times to make it really pure alcohol. Okay? All right, then let's talk about spiritus. So I need to erase. There's my eraser. So spiritus, or cleaning alcohol, I don't have a good name for it in English. I don't know what we call it. I don't know if we use it as much in the US. Cleaning disinfectant. Like a lot of the disinfectants we use in Corona time have a lot of alcohol in it, okay? Okay, and again, that's mainly, spirituous got really a high percentage of ethanol. But wait, but wait, no, don't drink it. Achtung, here's why. It's not pure alcohol, okay? They don't want people to drink it, okay? So, in spiritus or disinfectant alcohol, disinfectant ethanol. So it's the same, most of it's the same alcohol in beer and wine, okay, and hard liquor. But in spiritus, fusel oils or alcohols are added. So if you drink it, you throw up. It will make you sick. Hint, you don't want a little kid to drink this, right? And if a little kid did drink it, they would immediately start to throw up. That's why this stuff is in there, okay? I don't want you to drink it anyway, but a little kid may not know what they're doing. Oh, glug, 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 blah, okay? So, so you get sick and vomit, okay? Let's talk about what that's called. It's called, in German, vergelt. I'm going to try and spell it right. And in English, it's called denatured, which I really like that because it means not natural. It's made unnatural. Okay, denatured. Okay, so if it's denatured, they've added the oils or alcohols. A fusel is the type that we won't study that, but that's the name of the type of oils or alcohols added so that you get sick and you cannot drink this stuff. Okay, so it's made for disinfection, for cleaning. It's not made for drinking, spiritus. Let's see if you have any questions. Why can one use spiritus to start a fire? Because, Magdalena, it burns really well. In the same way that, like, gasoline burns, right? Gasoline is an alkane, has alkanes in it, right? Benzene. Um, Alcohol has an OH in it, but other than that, it's pretty much still, and the rest of it's an alkane. So it burns really well. It's got a C's and H's in it, so it burns quite well. In fact, it catches fire very easily, Magdalena, as you know. What purpose do these have? Lily, they don't have any real purpose. They're just added so people don't drink this stuff. They're not added for any other reason that I know about. Okay? Ute. Let's talk about beer. Okay? We all right so far? Okay. I'll be honest. I brewed beer for about 10 years in Montana. In fact, not to brag, but I won prizes with my beer. I was good. So here's the deal with beer, or anything really. It could be wine too. You need, ideally, did you notice it's glucose? So what if you don't use glucose? Remember, that was C6H12O6. Well, it turns out I can use something that we're going to study later this semester called starch. And what I can do is starch is like a combination of lots and lots of sugars all joined together. So it's many sugars joined. And what's cool is some of the enzymes, you guessed her, in the yeast break down the starch to sugar. So starch can be broken down by the enzymes into sugar. And then from there, of course, I can do, fermentation and then make ethanol and so on. Blah, 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 blah. Okay? Now, so to make beer, in beer, malt is used. Malt. And malt has starch. So the deal is, of course, I can use stuff with starch in it, and it can be broken down by enzymes to sugar. Same thing with rice or potatoes. All of those have starch that can be broken down. Rice, potatoes, and so on. Wheat, okay, all of that stuff. So that's why we use malt in beer, because it has a good flavor, but it has to be broken down into sugars by the bacteria. Okay. We also need hops, Hopfen. Where's my eraser? Right here. Okay. So in beer, need hops. There it is in English. In German, Hopfen. German speakers, is it an umlaut on the O? Is it Hüpfen or is it just Hopfen? I don't think there is one, but let me know if there's an umlaut or not, okay? Because that's always hard for me as a Native American to do that. Okay. Why? What do the hops do for you? Do you know? Anybody know? Without. Thank you, Larissa. Anybody know what the hops do in beer? There's more than one answer. Thank you, Mela. So anybody know what the hops do in beer? Okay, well, they do three things. They provide a bitter flavor. They can provide other flavors too. Some hops have a more fruity flavor, some a more bitter flavor. Okay? Yeah, exactly, Shilpa. They help to preserve the beer. So in hops is apparently kind of a natural preservative as well. Yeah, so bitterness, preservation, and oh man, there's a third reason. Can I think of it? Isn't that terrible? I always get down to here and I got to think of the third reason. I can't think of it. Let me look at my notes real quick. Sorry. Sorry. Hard to get good teachers, isn't it? Okie dokie. Let's see if I wrote it down in there. The short answer is no, but I got another folder here. Let's see if it's in this one. God, terrible. Is 4 reasons. Okay, so it helps provide bitter flavor and it gives an aroma, a smell. Good thing I looked. So flavor, aroma, actually that's 2 things, bitter and flavor. So bitterness and a flavor, it gives, preserve the beer and it gives an aroma. So that's kind of 4 things, but I'll put it as 3. Good. Okay, so I'm glad I looked because we sort of need to know that. Okay. Okay, so think of like beer. So we need like malt, which is the source of the sugar. The starch turns into glucose. I need the yeast, and I need the hops for these various reasons. Those are the 3 main things, and of course, water. Right? Okay. Most of beer and wine is water. Good. Let's see if you got any questions before I forget. Turns out the fizziness. What's the fizziness? That comes from what? What is the fizziness? Yeah, see, Shilpa knew that. The effervescence. What's the fizziness from? Go back and look at the reaction, folks. Yine, Larissa? Not from the hops, no. How does beer get fizzy? There's 2 answers. Yes, Tadashi, it's the CO2. Good job. So the CO2 from the reaction. Sometimes beer companies add extra CO2, just to warn you, okay? So now, so CO2 from the reaction. So when I did my beer, right before I bottled it, I'd put in a little more sugar and I'd reactivate the yeast. And then I'd put the bottle cap on, right? And so the CO2 could not escape. You know what I'm saying? So the CO2 stayed in the liquid. Now you can't add too much sugar. What if I had too much sugar right before I put the bottle cap on? What happens to the bottle of beer? I've had friends who've had this happen. What if I put too much extra sugar in the beer right before I bottle it? Yes, Magdalena, they explode. Now they don't like go crazy. They just sort of crack and then all the beer falls out. All right. So it's not like it's a bomb or something, but they do lightly detonate because there's too much pressure for the bottle. So you can only put in the right amount of sugar, which is about for 55 bottles of beer. That's what I used to make. 55 bottles is 0.33 liters per bottle. You add about a cup of sugar for that whole batch. So not a lot, just enough to get the yeast reactivated, create a little CO2, and that's the fizziness that Lily referred to. Okay? All right. Good. Good thing to ask about. Anything else? Any other questions about beer? Wine I know less about, but anything you're interested in. Let me make sure I've got this down. I do. Good. Yes. We're good there. Okay. How are we doing on time? We're doing okay. Then let's change gears. And I got to look at my sheet for the day and remind us. Okay, we did malt hops, we did distillation, we did. Yeah, we're going to start on that. We're going to start on that. All right. Does the color come from the hops? Noah, the color comes from the malt because I can use malt that's a real dark malt, which I've used myself, and it has quite a lot of color still in it from other organic molecules, and I don't know what those are. Or I can use a really light malt, and then the beer will be very clear, right? Like Berliner Kindle or some really awful beer like that. That's super, super clear, okay? But a nice dark beer is going to use dark malt, which has a lot of extra molecules. Some of those molecules are also what provides the flavor of the beer. And if any of you have drunk this sort of awful stuff called Maltz beer, it's sicky, sicky sweet, and it's not a beer at all. It's non-alcoholic, but it has a lot of malt in it already, and it's very dark. So that's a non-alcoholic. Yeah, not a beer, but it's called, I guess, Maltz beer. Yeah. Okay. Any other comments, questions about beer or wine? Huge. Okay, let me get the other sheet and we can start up here. What is exactly malt? Malt is kind of a type of wheat plant. Okay. Why is malt added to coffee? I have no idea, Magdalena. Maybe it's sugary tasting and people like to add that sugary stuff to their coffee. That's the only thing I could guess. Yeah, but I think malt is more or less a type of grain. A grain. So you can probably Google it quicker than I can find that, but I think it's a type of grain. Somebody can check me on that. Malt. For example, malted barley. Malted barley. Barley is the grain, and if I malt it, I make it so it can deliver its, from the grain, it can deliver its little starches to the beer. By the way, I used to buy these grains. Okay, you can buy them in the store, and then you got to crack them open with a rolling pin. Crack them open to allow the starch to come out when you throw them in the water. You know what I'm saying? Yeah. So malted barley. Barley is the original grain. Malted means I make it maybe a little roasted so I can get the starches out of it. Yeah. Good. Any other questions from you? I'll have you all ready for understanding the beer and wine industry. Okay, let's erase that. I think we got enough from beer and wine. Any more, and I'll start getting letters from your parents, so I don't want to do that. Okay. You think I'm joking, but in the US, one time I had an AP problem, AP chemistry problem that had alcohol as a chemical in it, and I got calls from parents because they thought I was trying to make their kids drink alcohol. It's crazy, crazy. It's a chemical. It's in the world. We need to know about alcohol. Whether you drink it or not is up to you. And that's what we're going to talk about now. We're going to talk about the effects of alcohol on the human body. The effects of alcohol on the body. Now, the sheet I'll give you gives a kind of a stupid quote. To be honest, I don't like it, but it gives you the wrong impression. I used to work with a guy who's since retired. He used to say, well, if I drank pure water, I would die. And the guy was kind of a moron. Why? Because if I drink pure water, I'm not going to die unless I drink only pure water and I drink a lot of it. Like if I drank several liters of pure water, this would send my body, which would not have salt in it now, it would get my body out of alignment. And I suppose I could die, but not by just having some ordinary water. Okay. Ordinary water without anything in it is just fine. Just don't have too much of it, right? Of course, I'm not going to drink 5 liters of water. It would be silly. Well, it's kind of this way with alcohol. Alcohol is essentially a poison. Okay. So ethanol is a poison for the body. And we're going to see what it does to your body and especially under what concentrations. Okay. All right. So let's make a list. So we're going to say concentration. Percent. And now we're going to do concentration in another way. You ready for this? Per mil. That's what they say in German, like milliliter. And it's part per hundred. Percent is 1 in 100, okay? Percent. Centa, like out of 100, okay? Per mil is, looks like this. For example, in our chart, the first thing we're going to do is we're going to say 0.05%. Well, this would be 0.5 per mil. In other words, 0.5 particles out of 100, no, out of 1,000 are the alcohol, or 0.05 out of a 100. So it's a small amount that I'm talking about. Okay, by the way, I'm going to send you this sheet. So, are there permanent effects from high concentrations? Yep. And we're going to get to the higher concentrations. If I don't get to it today, we'll get to another day, Shilpa. But we'll start out with the low ones first. So this is the effect. You feel stimulated. An old-fashioned English word is tipsy. In other words, you can feel the effect of the alcohol on your body a little bit, sometimes cheerful for some people. Then let's double that amount. So we're going to go to 0.10%, or per mil, it's 0. Let me make sure I do this right. No, it's 1. So 1 per mil. Your reactions are not so good. So the effect is, we say extended reaction time. You're slower. You don't think you are, but you are. Extended reaction time. You get some paralyzation. In other words, it paralyzes you. Paralyzation of the brain center. So some of your cerebellum, some of your brain cells, brain center, cerebellum. No, that's not a person. Cerebellum. Okay. Ute. Um, we're going to stop right there, but I'll tell you where we're going to. We're going to like 2, 3, and 4 to, no, 2, pardon me, 2, 3, oh, darn it. Here, let's make that clear, okay? 2, 3, and then 4, and then 5 to 6. That's where we're headed to next time, all right? So we'll talk more later this week about thank you very much, Sarah. We'll talk later this week about the effects of higher doses per mil and, of course, what those will be in terms of, but notice that even 0.1%, right? That's not 1%, it's 1/10 of 1% already has an effect of slowing your reaction down and paralyzing some of the cells in your brain. So it doesn't take much for this stuff to start to work on you. Okay, and thank you all. How much with a concentration of 0.1 would one have to drink to get the effects? No, it's the other way around, Magdalena. If I have like a drink, I'm going to get here. If I have a couple drinks, I'm going to get here. I will have this percent. Sorry, concentration in your blood. Can you add that, everybody, before we go? It's per mil in your blood. In blood. In other words, when you take a breathalyzer test or it's checking what's in your bloodstream. Okay? Good. We'll continue there next time. I'm going to send you an assignment to do, by the way, throughout the week, which will be on intermolecular forces, kind of a review assignment, and I'll grade what you've already done. Good. Have a good week. Bye.